We have another example problem. A 33 kilogram child bouncing on a trampoline can be roughly modeled as a damped harmonic oscillator. If the height that the child bounces to, the oscillation amplitude, drops to 1/3 its original value in 1.8 seconds, what is the value of the damping constant? So this problem is asking about the amplitude and how that amplitude is changing, which means out of our damped oscillation equations, we simply need the portion that talks about the amplitude. All right, so we know the mass of the child is 33 kilograms. We know that the height that the child bounces to drops to 1/3 of its original value. So we can say that A of t, this time, the amplitude at this time of 1.8 seconds, is 1/3 of A naught. So we don't know A naught, we don't know the original height, but that's okay. We know that the amplitude is now the 1/3 of whatever that happened to be. So we're essentially putting in 1/3 A naught in for the amplitude at this time we care about. I'll put in the time and the mass as after we have symbolically solved. But I wanted to plug in this 1/3 A naught right now so that we can see that A naught is actually not needed. We don't need to calculate A naught since the amplitude at this time is in terms of that original amplitude. So we have 1/3 is equal to e to the negative bt over 2m. Since we have the exponential function by itself, we can take the natural log of both sides, and that will leave us with just the power on the right. We're looking for b, the value of the damping constant. So if I solve for b, I have negative 2m over t that I have to bring over. So the mass is 33 kilograms. The time is 1.8 seconds. So B, when I plug these numbers in, so 2, 3, I have essentially 3 sig figs from the 33.0 and the 1.8. We're assuming that 1/3 is exact, so more significant than 3 digits. I'm getting 40.3. The units are on my numbers. I don't have to memorize the units of B. I can look at the numbers I've plugged in, and those tell me my units as well. So here is B for this particular problem. And yes, that is a large value.